Hi, this is Eric Pan from C Studio, and thank you so much for having me to this talk. I'd like to share with you what we have been done with generic Node, and we have been the hardware partner for a lot of pioneering LoRa devices, and there's a lot of pain and gains, and I hope we can facilitate your projects in the near future. So briefly speaking, CETA has been in this business for 2008. We provide a lot of open source hardwares, compiling with Arduino, Raspberry Pi, JS Nano, etc. And from 4 years ago, we started to make more devices that can be really used in industries. And we work closely with makers and developers to cook the IoT solutions that can be just deployed and delivered. We are hoping that the open source technology will enable more emerging scenarios, all the way from agriculture, transportation, smart cities, etc. And this is how we started. We provide a lot of modules. We work with Arduino to make the modules from 2008. And Groove has been quite a popular system. We keep doing more peripherals. It's a modular system. People can, whenever they have an idea, they can really quickly turn that into the proof of concept. And now we are very much familiar with a lot of hash environment. How do we to sense the data in the hash environment, no matter it's like super cold, it's humidity, it's water. But to get more data from our field, LoRa provides the great accessibility, it's great distance, but how do we make sure the sensors are working reliably? So this is where we are going, from productivity from possibility to more productivity. And so we have been around the ecosystem, around the hardware mission. We provide the core modules. We then give people the dev kits so they quickly combine and use them for small ventures. And also we enable more people with design and manufacturing services, which we have been carrying out for many years. And we also give people like presets of LoRaWAN sensors. And it's very key that the hardware itself is not resolving the problem. It's providing fundamental for more digits, more data. And we closely work with TTN, Microsoft, and other companies to ease the process of bringing it into production. And so that's where we encounter the LoRaWAN devices. It's perfect. It's perfect timing because it's one LoRaWAN node and enabling many use cases. And it has a lot of built-in features that enable free jumpstart adoption. And it's also open source. So the way we do it after we get an inquiry is breaking into several phases. Generally speaking, whenever we receive hardware demands, it starts from the idea. And with the open source modules with generic Node, it's very easy to make the first prototype. As well is the EVT, we call it the engineering verification test. And it goes on, people trim the product into smaller form factors, trim into the enclosures, and which target to be get manufactured, that's the engineering sample, we usually call it DVT, design verification test. And also, it goes up to the pilot run to manufacture for a few hundred pieces to verify the process, to verify all the quality control in space, and the stability and the consistency are managed across the different units. And then we go to PUAT, like in large quantities, apply a lot of the improvements, also the certificates in place. And that's where a lot of early adopter or beta users start to get a hold of the product and move on to the next stage. And TTN is in the middle. TTN, whenever we receive the TTN design, it's already very professionally made, or the injection mode or the PCB layout, they are finished. So what we are focusing on is how do we bring the first engineering sample to small batch manufacturing, so hundreds of them in months. So The key to do that, I think we have a natural benefit is generic node is a derivative from many open source hardware, and we share a lot of biomaterials and the process on many projects we are familiar with already. And also we integrated with the Shenzhen tech ecosystem, so we can rally the processor materials to fulfill the manufacturing process. And also, we have a well-trained professional engineering team to work closely with TTN to make this happen. And also, I think a key concern for this industrial level stuff is how do we do the test quality management. I think we take from 1 to 2 weeks for the kickstart. It's the initial conversations. We understand the constraints. We communicate clearly about the projects. And from the day one in the conversation, we know the whole picture and we define the process, the success of the projects together. And as the project goes on, it's a design verification. It's very critical that whatever you have designed works for the first piece and works for the many thousand pieces afterwards. It's a lot of careful engineering know-how, and we need a lot of experience to consolidate in the process. And we listed a few of the checklists you should look at for that process. And after that, you should pass the certification of different popular countries in target markets. It's we need to do the FCC, CE, and all the technical ROS, and for all the way from engineering process, wireless radiations, and also material costs. During the production, I think that's where people usually care about the quality control. That's much easier because things are already in place because of the works in several months before, and people just rely on the verified, confirmed test plan and quality control, and finish the production in a consistent manner. But for the outdoor manufacturing, it requires a lot of reliability tests. The biggest challenge we face these days is actually on the supply chain. I mean, everybody knows it's like a turmoil. It's much worse than any time we've seen before. We track the list from Supply Frame. They have very good monitoring on different materials across time domains. We see a majority of them are in shortage in high prices. You don't know out of your biomaterials how many of them are going to be in shortage. So we have some tips we practice during the TTN generic node. Is first, you stock whenever it can be stocked. You just have it's not like before. Whenever you decide to go with the project, purchase component before it goes bad. And whenever you design something, you always keep in mind that you should have alternatives, and you should be front and also be aware of the spot market. Like especially in Shenzhen, there are so many components you cannot buy from the official channels, but they are in the spot market. We need free. It's not recommended, but sometimes you have to make sure you get the components and you should verify them, and you build the mutual trust and long-term collaboration with spot market. That's save some assets, because a lot of the times you're just missing 1 or 2 components for a few hundred pieces, and that will be the gaining factor for the whole great project. And also, I think TTN has done a great job to win the support from the silicon providers, because we are starting with a small project, but their confidence over this project will give you extra support, and you can get some urgency or buffers or allocation from other customers if they don't need them anymore. So it's very key for silicon providers. So to wrap up, for any project that's starting with an idea, we call it 0.1, it's just idea. You need to have the proof of concept, the prototyping. Thanks to open source hardware, it's becoming much easier. You can do them in days. And whenever you have the engineering samples, you do change the PCB, you trim them, and prepare the test plan, etc. It takes several weeks to get prepared for the pilot run. But what we're targeting to do is to wrap the whole thing for large production in a few months, give or take. Thanks to the supply situation, it has to be a strong fight. But for the first, I think for the first beginning, the idea is how do you measure the return versus investment? How do you do the think about ROI during the idea? That's critical for the whole project. That's the why of the many successes. And during the proof of concept, you need to worry about the time versus conscience. You can have endless considerations, but with limited time, you can only prove. And I suggest that the less is more if focusing on the most important functions. And for quality, and during you're doing the engineering samples, it's more important to worry about the quality and reliabilities. Reliability means long-term quality. You need to have a lot of experiments to make sure that's working. And there's a lot of mathematics to think in that way. And when they ramp up to pilot runs in a few months, and I think we usually worry a lot about the cost and improve the cost by working better with the supply chain to optimize manufacturing process, but also to hear the user feedback. I think that's a key stage where you decide to go forward or kill this project. And whenever it goes smoothly, I think it's to keep the balance between demand and supply, especially everything is in dynamics. And this project can just go fly high, but whenever you need to make sure they have continuous supply. So it's not easy to scaling the Planeering devices, but thanks to TTN, we have the generic node, which is becoming a jump starter for everything. And we are happy to help you to provide more scale Planeering devices. And we are in the ecosystem to work with TTN, with Semtech, ST, everybody, and looking forward to collaborate with the ecosystem even deeper. We are very confident about the neural networks, and we see a lot of interesting breakthrough projects and hope to enable your success. Thank you so much. This is Eric Pan. Looking forward to hear from you sometime soon. Cheers. Stay safe.